Welcome back. There are two topics for this video. The first one we are going to cover are the SI units and the metric system. So, the metric system is very similar to our English system. You'll see units such as length and mass. You will notice that some units are familiar, like the liter and the second. Some may also be familiar, like the meter for length and gram for mass. And some that you may be less familiar with are things like the mole. We'll talk about that later in the semester, or Kelvin for temperature. And we will use Celsius and Kelvin in this class for temperature. And you can also see the abbreviations there. Okay, so it will be good to become familiar with those abbreviations. Now, in the metric system, they use prefixes, okay? And these prefixes contain what's called a multiplicative factor. So they tell us whether the unit is larger or smaller than the base unit. And the base units are those units we talked about in the previous slide, like grams or meters. So there are four prefixes that I do want you to key in on and memorize that are on this slide. Okay, and that is the kilo, the centi, the milli, and the micro. Okay, so do try to watch, especially the abbreviations as well. You will want to memorize those, and that's because these are the four that are used most in the healthcare system. Okay, so if you notice from the deca and up, so if we look from deca to giga, and let's just 1 second. There we go. Okay, so from giga to deca, notice how the multiplicative factor in scientific notation here are all positive values, and also notice how the multiplicative factor as a standard unit are all greater than values of 1. So that means that these prefixes indicate that the unit is larger than the base unit. So say a kilometer is going to be longer than the base unit of a meter. Okay, and then if you look at deci down to nano, you'll notice an opposite pattern. Now the multiplicative factor becomes negative, and if you look at it in standard notation, you'll see that those are fractional units, which is 1/10 and 1/100th. Okay, so these prefixes indicate that you have a unit that is smaller than your base unit. So again, like a centimeter or a milliliter is going to be smaller than the base units. Okay, so again, the prefixes to memorize are listed here. This is a good time to create 4 flashcards. And notice how we always put the 1 next to the prefix. So 1 kilometer is equal to 1,000 meters. Now, you don't have to do this, right? Sometimes when you look at the conversion factors in certain tables, and we'll see it later in this video, you may see 1 meter is equal to, say, 100 centimeters. Okay, so be ready to see them listed either way, but my recommendation to you is to memorize them as they are written here. And it's up to you whether you would rather look at them in the standard notation, which is the first part, or if you would rather use the scientific notation, which is in parentheses next to it. Okay, so you decide, but please memorize these 4. Okay, now the next topic we're going to dive into are converting units. And we're going to spend most of this video looking at conversion factors. Okay, so what is a conversion factor? Well, it is a way for us to convert from one type of unit to another. So say from the English system to the metric system. And some common ones that we will use during this course are going to be the pounds to kilograms. So 2.205 pounds is equal to 1 kilogram. So you can potentially set an equal sign between these. And again, 1 inch is equal to 2.54 centimeters. Okay, so it's just a way for us to convert from either the English system to the metric system, or possibly within the metric system units using those prefixes that we just learned about. Now, when we're setting up conversion factors, they could be given as equalities or in a table like we just saw, or they could be put into phrases that we'll look at in a minute. But we need to put them in a way or a format that is usable for solving problems. Okay, and the way we do that is to set them up as fractions. Now, when you set these up as fractions, please make sure to always include a unit next to every number. Okay, so an example here, we have 100 centimeters is equal to 1 meter. And again, this is the other format for that equality. You could also say 1 centimeter is equal to 0.01 meters. So when we get this equality, we want to keep the 100 and the centimeters together as a package deal. Okay, those have to stick together like glue. And if I want to create a fraction, I can put the 100 centimeters on top, like we have here, and the 1 meter below it on the bottom. So again, that 1 meter is a package deal, and it goes on the bottom of the fraction. So I can keep it this way, or I can flip it, and when I flip the fraction, again, notice how I have to keep the 100 with the centimeters and the 1 with the meter. Okay, it's very important that that number and unit stick together like glue when you are flipping these fractions. So let's look at some other examples beyond equalities. Let's look at phrases and fractional units. So most of you have heard of miles per hour as a phrase. Okay, that can also be used as a conversion factor. So what you have to remember is that the 45 goes with the miles, and then per, we can insert 1 per 1 hour. Okay, and then you can create your fractions as you see here. You can put the 45 miles on top and the 1 hour on bottom, or again, we can flip it, but when we flip it, the 45 has to stay with the miles and the 1 with the hour. Another example, one that we'll use several times this semester, grams per centimeter cubed, or grams per cubic centimeter. Those are units for density. And so most of the time when you see density in a problem, it's going to be given to you more like this, the 0.13 g/cm cubed. Okay, but again, always remember that 0.13 goes with the g, and then we can insert next to the centimeters a 1. So again, this is per 1 cubic centimeter. Okay, and again, we can either have the grams on top and the 1 centimeter on the bottom, or if we want to flip it, the 0.13 has to stay with the grams if you want to move it to the bottom, and then the 1 has to stay with the centimeters. Okay. So last set of examples here, we have phrases such as 80 kilometers per hour, which we have seen, and then the last 3 are dosage examples. Okay, so we're going to see these quite a bit in class, where we have tablets containing, or tube holds so many kilograms. And again, you can insert, instead of a tablet, we can say 1 tablet. So 1 tablet contains, or is equal to, 250 milligrams of ibuprofen. And then you can see how that conversion factor is created. Okay, and same thing with tube. We can say this is 1 tube, and instead of holds, equals 0.070 kilograms. And then it's easier to see how the fractions again are created. 1 tube equals 0.07 kilograms. And keep in mind that if you want to, it may help to see the fraction symbol as an equal sign. So write 1 tube equals 0.07 kilograms. Okay, let's practice just a couple of these. So we'll skip on to the 0.84 grams per milliliter, and we want to write 2 conversion factors for this. So we're going to start by assuming it's per 1 milliliter. Okay, and that per sign is kind of like a slash or a fraction symbol, so you may also see this as 0.84 grams. G is the abbreviation for grams per milliliter. Okay, and then we can create our fractions where we get 0.84 grams per 1 milliliter. And then if I say I want to flip it, so if I want to have the milliliters on top, just remember the number has to stick to the unit like glue. So we put the 1 milliliter on top with the 0.84 grams on the bottom. Okay, so we will end this video here, and then in the next video we will work on some practice examples of using the conversion factors to convert from one unit to the next.